Greetings, the Astro 30 here again, and the saga on the power supply continues. I still haven't received the modules. It's been about 14 days since I replaced the order, but I'm going to be getting on to something else in the meantime. However, I did manage to find a set of instructions by looking through various different YouTube links of the same particular module being assembled, and this instruction manual, which is not really all that intuitive, but it comes off the Banggood site, so it is freely available to anyone who wants to see it. And as it says here, instructions of installation of the 0 to 30 volt stabilized voltage supply. The technical specifications of this, I did actually get the input voltage for the transformer correct. Now on the board they have a 3-terminal connector with 2 outer connectors and a center one, so you could actually use a 24 volt center tapped transformer. That's like 12012 on the same board, but of course your current capacity of your transformer needs to at least be 3 amps. So the alternating current input 24 volt maximum apparently, but judging by the filter capacitor that they've used on the input, its working voltage is 50 volts, so you could easily still run this up to like 28 volt, but don't quote me on that. Input current 3 amp max, as I just already said, and the output voltage is 0 to 30 volts, could be regulated continuously, which is not a very good English sentence. So that's our instructions. You get parts list. There's a little bit more to the specifications. It just says output limit current is 2 mA to 3 amp, could be regulated continuously. So as I just said, they mean that it can be operating in constant current mode and constant voltage mode. Output voltage ripple is 0.01% maximum, so the ripple on the output would be pretty average. And the size of the PCB is 84 by 84 millimeter square, so it's only a board about that big, not very big at all. So technically speaking, that plastic case that I was originally off. Okay, and get interrupted by a telephone call for telemarketing trying to sell me life insurance. Anyhow, as I was saying, the PCB size is pretty small, 84 by 84, so technically speaking that would have fitted in the plastic case that I was going to install it in the first place. It would have been tight, the transformers would have fitted, the 2 boards would have fitted side by side. I was going to put them on top of each other, but yeah. And still enough room at the front panel for all the controls. So if you wanted to build this in the original direction that I was going, you could. You'd have to use 2 small TO3P transistor cooling fins, but if you use a small heatsink like that, as they intended in the kit, you're gonna have to put on fan assisted cooling because the heatsink is too small. Because don't forget, 30 volt at 3 amps is a dissipation of 90 watts. So the heatsink has to be able to dissipate 90 watts of power. So that little TO3P cooler that we're going to make you use on the kit is going to get quite hot. And I wouldn't suggest going any smaller than that. If you're going to use the size that they describe, put a fan on it. Or just use a bigger heatsink and mount the transistor off the board, which is what I'm going to do in this instance. So as I said, we've got a list of components here. It's the installation steps. You just install resistors, diodes, etc. The smallest sized components to the largest sized components, as in physical size. We'll get to that in a later video. This video is going to be again just hardware because I don't have the boards. There's a couple of pictures. I like the Chinglish of these instructions. The potentiometer could be placed directly onto PCB. In other words, they're talking about these voltage and current knobs. Here's one here. Or you could also have them off the board to mount to the front panel separately. Because in the kit they do actually provide you with some fly wires and some header connectors that you actually can plug the wires into, and then you can you know, have them off on the front panel so the board can mount anywhere in the case you want. But I just like the English in this. So continuing on, they go into circuit conditioning, which means basic setup. There's a small little trim resistor on the board that you've got to set your 0 volt out. So you'd put your voltage knob all the way down, your current knob all the way up, and then you'd stick a multimeter on the output terminals, and you adjust RV1, they call it, to zero out the voltage. You want to get that voltage output as close to 0 as possible. It could either be in the minus, it could even be in the positive, so you've got to put it on so it's 0. So that's the first part of the setup. And that's basically it. The second bit is just current calibration. That is, if you want to calibrate the dial on your knob, you would set it at a certain voltage with a 10 ohm, 10 watt resistor, and then you'd measure it until you get 1 amp, 3 amp, etc. And then you mark on the scale where those current limiting parts are on the control. And that's basically it for that. And they give you a circuit diagram. The only annoying part about it is they only show the part number reference. They don't show what the actual value is. You've got to go back to page 2 of the documentation and page 3 to look up the values. So I have done something else. I have redrawn the schematic, so it's a little bit more larger and better laid out with the component values actually written on the schematic. Now I'll put a link in the description to the original installation manual plus my redrawn schematic. So let's look a little bit more in depth at the circuit. I'm going to start with the output stage over here. We've got our main power transistor Q4, which is a 2SD1047, and we've got this driver transistor, which is Q2 2SD882. And if you look at the topology, for f***'s sake, and if we actually look at the topology of this circuit, this is actually a Darlington output stage. And this is a Darlington configuration output. Now you can actually buy transistors which has this exact topology. You've got a smaller signal transistor driving a larger power output transistor with a resistor in the emitter circuit to base of the output transistor. And it's called Darlington because of the guy who invented it, Sidney Darlington, who was an American electronics engineer. Now, the reason we use a Darlington configuration as an output stage is because we get higher gain and or higher current capabilities than just using a single transistor. And the way the gain's worked out is gain equals Q1 gain times Q2 gain. So say this first transistor had a gain of 100 and this one had a gain of say 200. It'd be 100 times 200, which is 2000. So the overall gain of this circuit is 2000. This resistor actually is kind of important because it stabilizes the entire circuit. Now, as I said, these can be already bought in a single TO3P type style package with a base, a collector and emitter. So the emitter of the first transistor is connected directly to the base of the second transistor. Just ignore this resistor for now. The two collectors are connected together, which form the collector. The emitter of the second transistor is the emitter, and the base of the first transistor is the base. And that is the Darlington configuration. Now I'll put a link in the description to a more in-depth discussion on what actually this resistor is for and why it is there. But for now we'll just leave it with that, and I want to keep things as simple as possible. All I've done is used a BD139 MPN and the 2N3055 MPN. These transistor values could be anything. As long as one's a power transistor and the other one's a signal transistor, you've got a Darlington configuration. And you would be forgiven for thinking that this looks like actually a amplifier output stage. Well, technically it is, because the Darlington configuration is actually used for power amplifier outputs on audio gear. Dave L. Jones from EEV blog has a video discussion on the design of a power supply using op amps, which basically explains how this circuit works. It's not the same topology, however, but the theory behind it is the same. So to save me having to explain all that and fumble and fart around with my words, I'm going to just leave a link in the description so you can go and watch that series of videos. Plus it gives him more views. And this output stage is connected directly on the positive line of the bridge rectifier, so this is what's known as a series pass element or a pass transistor. So you can imagine, forgetting all the op-amp schematic over here, that if we had a 3-terminal adjustable voltage regulator in this circuit and then connected this output stage across between, well, the collectors would go to the input of the adjustable regulator, and the emitter would be connected to the output of the regulator. So therefore the current is going to pass through the transistors rather than through the regulator. For a basic understanding, that op-amp controls the current, that op-amp controls the voltage, that op-amp is basically a buffer for the voltage. In a voltage regulator, current adjustment comes first, that's then series passed on to the next stage, which is the voltage adjustment, which then finally passes on to the regulation circuit and then the output transistors. So say the current was set for a 1 amp limit and you had the voltage set at 10 volt and you're at 1 amp. If you increase the voltage knob, if it's in constant current mode because it's set to 1 amp now, the voltage will not increase because this will try to take this down to keep the current flow at 1 amp. And that's basically how current limiting works anyway, is it'll either decrease or keep the voltage at a constant level and won't allow you to increase it, so that the current remains constant, hence the term constant current. Anyway, that's enough talking about this bloody circuit, which I'm still waiting for the bloody boards for. I'm going to move on to something else now. So always when I'm trying to shoot a video, the phone rings. Okay, so today's little exercise is to do the rest of the hardware that needs to be done, which is mounting the transformers internally, wiring up all the main side wiring, etc. Now I was doing some thinking, get rid of that, doing some thinking which could be dangerous, in my case it usually is dangerous, that this heatsink that I was going to mount to the rear of the panel there, I'm still going to do that. However, what I was going to do was I was going to mount the transistors through 2 holes through this. Now I'm not 100% sure what material this is, so I'm just going to look that up. Okay, so after double checking the description on JCar for this, both these front and back panels are actually aluminium, so they're just pre-painted and have a slight rough texture to them. So that's perfectly fine. What I was thinking is if this was mild steel, steel is not a very good conductor of heat, so you couldn't mount the transistors directly to this panel and have the heatsink behind, because you would not get very good heat transfer through the steel. But because this is aluminium, as long as between the back of this heatsink and the back of this panel you smear a liberal amount of heatsink compound on there, then this will work fine on its own with that as a heatsink. Because I was thinking I might have to go in here and cut out a large hole to allow the transistors to mount directly to the heatsink behind, but I don't. So if I can save myself some work, I will. So I'm also going to get rid of this. I'm also going to have to work out where the active comes in and the neutral come in on this switch, because this has a neon bulb in it. So I'm going to need to know where to connect my primary input, because one side will be switched, one side's unswitched, and we don't want the side that's non-switched to be glowing all the time. So we're going to have to work out with the multimeter where it goes. And seeing as I've got that grinder tool, I might take this panel out and just grind off about probably 15mm off the front and back, just to make it fit in there a bit better, because it is a bit, yeah, how you doing? This is actually coming into contact with the panel here, so it might be pushing it slightly out of square. So I'll just cut that off and, you know, straighten it, and I'm going to drill the holes through this heatsink, remove that label, drill the holes through the heatsink so it can be mounted to the back panel through those holes. I'm going to have to deburr those holes, obviously, because they haven't been deburred yet. In fact, I was a little lazy when I was doing this. I didn't deburr any of the holes. That's naughty, naughty, no, no. But anyway, moving on. First I'm going to clean this label off. I'm going to clean the label off on the panel there. I'm going to take this all back apart, and I'm going to cut this panel down, clean that label off as I said, and then we'll get into working out where to put the transformers. I'm not sure where the holes are going to go for the board, like what distance they are apart from each other, because I don't have the boards. So the holes for the two circuit boards will be drilled later, but I'll drill 2 holes for a transformer, 2 holes for a transformer, 1 hole for a terminal block, and 1 hole for a ground connection. Okay, and the easiest way to get these labels off is with a bit of glass cleaner, and let it soak into the paper for a bit, and then we can start sort of easing it off. And because it's glass cleaner, it's not going to hurt the surface of the desk. You can sort of see how much easier it is making this, getting it off without, you know, you pull a bit off and it tears. This is actually helping it to move the label and adhesive off of the heatsink, but keep in mind the adhesive will still be left behind on the surface, so you're going to have to use like isopropyl alcohol to clean it off. So using my handy dandy isopropyl mitre cleaner spray, and as far as I'm concerned that's good enough. There's still a tiny bit of residue there, but yeah, that's done. So before I get too excited and take it apart, I'm just going to mark with a pencil which direction the front panel is, because these holes are being custom reamed and drilled to fit in a certain direction. And I also know which way is up as well. Wherever the pencil mark is up is the bottom inside edge. And the reason I'm going to be cutting the edges off of the front and back of the metal chassis is, well, to allow the locator pins that come up for the top and bottom panels through the edges here to actually come up through the bottom and top properly. Okay, and with that we are left with the back panel and the chassis, so to speak. So again, I'm going to spray that with some Windex and let it sit for a minute. I just have to get the remains of that sticky crap off. Once I've actually drilled the holes for the transformers and the terminal block and the earth tag, I'll know which is the back and which is the front anyway. Having the piece of aluminium panel out like this, which I can actually now see is nowhere near square along this back edge. If I put a T-square up to that, I can guarantee you that this edge is completely out by at least 4mm on this side. Anyway, I'm going to fix that up with my mini grinder. With this panel out, it's going to make it a lot easier marking out and drilling the holes for the transformers and other hardware. When I get the boards, I'll probably take it apart again, drill out the holes, or I might leave it together. So if you look at the right hand edge, that's almost flush with the metal. If you now look at the left hand edge here, you can see it's at least 3mm out by the time it gets to that corner. And even though 3mm doesn't sound a lot, that's the reason why it doesn't look square in the case, is because the left hand edge, back edge, is 3mm out. So I'm grinding it down, taking about 15mm off the front and back edges anyway, so it won't really particularly matter anymore. And there we go. I've got 2 lines of reference now to line up when I'm cutting. Now I'm not going to use a hacksaw, but yeah, I will trim that panel down. So I've got my little straight edge jig set up. I've got it so that I can see the edge of the line with the edge of the wood. and all I've got to do is run the grinder blade up against the edge of the wood, or as close as practical to it, and then take a grinding wheel or something to it and then grind it, file it flat. The grinder was taking way too long, so it was just as easy to cut it with a hacksaw, which is what I ended up doing. It's a hell of a lot straighter, or hell of a lot squarer than it was to start with. That was the worst edge. So yeah, that's nice and square, so all I've got to do is just do the other side. That's about as good as I'm going to get it, I suppose. I don't want to be too fussy with it, or I could be here all day. So I'm going to say that that's done. That's also not too bad on the square. It goes out by about 1 millimetre towards the middle and then comes back again, so that is a lot squarer than what we started with. So I'll just double check with the front edge, which I think I've already checked. But yeah, same thing. There's probably about 1 millimetre difference towards the middle, but it comes back square again towards the edge. So yes, that is now perfectly 90 degrees on all corners. So that's a win-win. Now moving on to the heatsink, I have already deburred those 2 holes where the screws go through for the transistors. So let's move on to the heatsink. Take a 6.5mm drill bit. Just going to make sure there's no burrs where the drill came out to the other side. So that's all I need to do. That's the heatsink done. Okay, and that's it on there. We've got 2 15mm bolts, which are probably too long. M3 thread with some 2 washers going through the panel with 2 nuts. Don't need washers on this side because the transistors will act as washers, and then you use an isolator, then put the nut on, and you're done. But as I say, there is a fair amount of thread sticking out there, so it might be a bit too long. Not too sure at this stage, but I'll leave it alone. But yeah, that's how it's going to look on the panel. Of course, this comes back off. Because the size of the holes are drilled to 4mm, I can twist it almost a good 10mm side to side, so I can line this up pretty straight. So obviously it's got to come back off because you've got to put heat transfer compound on the back and then sandwich the 2 halves together. So that's that part of the puzzle done. This is getting interestingly fun. I've got one of these transformers. Now there's actually 4 mounting holes for it. Technically you only need 2. So I'm going to roughly guess, I'm only going to use the 1 transformer, but I'm going to roughly guess where I need to come in for my drilling, because I want to leave a bit of space at the back, so I can put it up about that far, I guess. Probably about 40mm. Yeah, I'll say about 40mm in from each edge would be about accurate. And grab a pen. Now, if I go the 2 holes diametrically opposite, like so, that gives me a rough idea of where the first transformer is going to go. And now, if I take that and I draw a line all the way along, I draw another line all the way along. It doesn't matter if it's not perfectly straight, and then I just guess the placement of the second one. Now I just need two other holes, one for the terminal block, which I can mount. I'm going to mount the terminal block, yeah, roughly, I could probably mount it in the middle of the two transformers, can't I? So I'll put a hole there and a hole there, roughly central to each other. One's for the earth tag, one is for the terminal block. But as long as it fits together and comes apart with very little to no effort, then we know that we have succeeded. And it is a bit hard to get apart again, but there we go. So now I know that it fits in the bottom. Pull it out of its bottom and start thinking about mounting some hardware. Alright, so I got one of the transformers mounted in there. I'm doing the second one. So what I'm doing is I'm taking a bolt and putting a washer on it. This passes up through the bottom. Then the transformer goes in. Then I grab another washer, put it on top, and finally a nut. So that's how I'm mounting that. So I'm just going to tighten my nuts. Do a Scotty Kilmer and go, "Ugh!" for a dramatic effect. Sorry, Scotty. Actually, no, I'm not. Now, do the second one. Okay, I'm going to stop doing that now. Right, so that's the two transformers mounted, albeit, well, they look pretty straight to me. So this is the story so far. We've got the two transformers mounted. Yes, it's bowing the metal a bit, probably by about 2mm or so, but that was to be expected. So anyway, I'm going to cut and mount my terminal block here. I'm going to mount a 10mm M3 bolt, washer, nut, and then mount a eyelet. One of those. I changed my mind yet again. Okay, and a short time later there's my terminal block to mount the two primaries joined together in parallel into, and then two out to go to the switch. Got my earth tag. They're probably a little bit close, but they should be alright. It does wobble a bit when you put it down or bump it. So what I might do is I might, on the underside of this in the direct center, is mount a self-adhesive rubber foot so that when it actually sits in the bottom panel, it's actually pushing it up. So I've got plenty of them. I can always buy more if I run out. So I'm just going to quickly turn it over and we'll have a look. So we've got roughly 6mm here, and I've got these rubber feet. Won't quite, well, it'll stop it from bending in too far. So what I might do is I might mount two of them just so far apart here, just to give it something so when it's actually down in the bottom, it's not going to be sagging down so much, and if it bounces up on the desk like it was doing, it's not going to make a noise. And with a lot of Chinese manufactured stuff, they do this all the time, just to, you know, suppress noises and stop things wobbling about. And that's all I should need to do. So it's starting to look like a power supply. All I need now is the circuit boards. But anyway, so I'm going to now do the task of wiring, the internals like the mains wiring. These secondaries I'll leave as long as possible until I get the boards, and then I'll cut them down to the correct size. These mains input ones can probably be left at the length they are. I might chop them down, I'm not real sure, but all they've got to do is just go up to this point of the terminal block down here, so they don't have to be that incredibly long. So I'll get to doing that, and we'll come back shortly because I've got to then work out the switch. Okay, that's the socket back in. I actually put another piece of heat shrink over the top and melted it with a soldering iron to make it look a little bit cleaner. And yeah, in case anyone's wondering why there is a piece of heat shrink over the top of this active wire, well, whilst I was soldering in the earth wire, I just realised that the soldering iron, the butt of the soldering iron, was resting up against the transformer's wire, and it started melting through it, and it actually did breach the insulation. So I just stuck a small bit of heat shrink over the top, and as you can see I've cable tied the two primaries so that they're not flapping around. I've still got all this active and neutral wire coming out here, so that hasn't been cable tied yet. In fact, I might do that first because it's only got to go to here. Ooh, that fart stunk. Okay, now I've got it cable tied together, and I've also cable tied one end. Oh, that stinks. Cable tied one end to the chassis so it stops it moving around, and I've cut it down to roughly that length. Now I've got to work out this switch. Now this is highly dangerous and not recommended, but the only way I'm going to determine where the neon part of the switch is to actually put two jumper leads across the back of the switch on the top two terminals here, for instance, and across the two wires coming off the IEC socket. Now remember, there's going to be live AC here, 240 volt, so because this chassis is earthed now, you do not want any of these wires to come into contact with the chassis, because if you're unlucky and the internal fuse here doesn't blow, you'll blow your circuit breaker or your house fuse. So if you're doing this, what I'm doing with jumper leads, you're doing so at your own risk. So I'm just going to plug the IC plug into the power, and I'm going to plug it into the unit. And right now there's no neon. And now we have a neon. So I now know that these two here are the AC input, and the ones at the bottom are the AC output. So this is the switch side at the bottom, and this is the unswitched side at the top, so the AC comes in here. Now I believe that these two pins are spaced slightly closer together than the bottom two. I could be wrong, but anyway, now I know how it's supposed to be wired. I can go ahead and wire the AC wires coming in off the socket to that. Remember, the wiring of AC voltage is and can be quite potentially lethal. So unless you're confident and know exactly what you're doing, don't do it. Oh, I just farted. Oh, and again. Switch is off. Switch is on. Power goes off. Power goes on. Power goes off. Anyway, so that switch is working. So now I can, well, add some cable ties to this and then connect it to the terminal block. I've measured across the terminal block where the two primary windings are connected to, and I have got about 19 ohm of resistance across both of them. They're actually about 37 odd ohm in impedance across the primaries, and of course resistors in parallel divide, so I'm getting around about 18 ohm. So first I've got to work out where I'm going to route the wire. I mean, do I use all this length and just route it back, or do I just cheat and go across? But I've got to remember that I've got circuit boards sitting here, and I don't want the main section to be anywhere near the secondary if I can avoid it. But that would mean using a length of wire for no reason right across to down there. So I might make it about that long so it can be tucked out of the way underneath the secondary wire there of the transformer. So yeah, I'll do that. So the two primaries are now wired together. I've got one of these things, which is a self-adhesive little anchor point that you can put a cable tie through to anchor it to a chassis, which is exactly what I've done. That keeps the wire nicely out of the way. So all that's left to do now is to test the secondary outputs. Now I'm going to need to make sure that these don't come into contact with anything, so they're going to have to be propped up or held with something up out of the way. Okay, got them mounted in the claws of the helping hand there, so they're just propped up out of the way and they're not touching each other and they're not touching ground. So as you can see, I've got a meter there in the background. I've got the leads connected across one of the secondaries of the transformer, and I'm just going to measure the voltage. So I'm going to plug this in. It might have helped if I plugged it in first. It doesn't matter now. Right, so that's plugged in. Turn on the power. And I've got roughly 25.8 volts there. So 5.7, 5.6. So that's pretty good. So that's a little bit higher than 24, but that's fine. Measure the other transformer. Again, if you're following along at home, you're doing so at your own risk, because remember, mucking around with live wiring can be dangerous unless you are confident that you, come on you sod, that you know what you're doing. Don't do it. Okay, get that out of the way. Press the power again, and that's about the same, 25.8. So I'm happy that now the mains side of this project is now wired. And I think that's where I'm going to leave this video for today, because this has gone on long enough. And now on to that surprise that I said to wait for in the description, and no, I don't mean the laptop. In the process of going out and getting some cigarettes and something for dinner tonight, I passed my post box and they have arrived. My two power supply modules have now arrived. They're sitting here on my desk ready to go. I'm not going to assemble them now. Now I'm not sure which seller this came from, whether it came from the original seller, the replacements, or it was the second seller's ones, or it's the original ones in the first place. I don't know. Don't particularly care. They're here. I can assemble them. So I'll be doing that in part 6, and part 6 will be the final video in this series, so look out for that. My next day off is Monday, which is the 22nd of January. It's currently the 18th, but this video has gone on long enough, so I'm going to probably maybe assemble these tomorrow and do it over several days when I've got time. I am happy and stoked. I'm excited. I'm so excited I could just shit. So the last piece of the puzzle is complete. Anyway, if you enjoyed this video, please remember to rate, comment and subscribe, and you can always follow me on Facebook and Twitter. The links are in the description as usual. Anyway, this is the Astro Thief saying, see ya, have a great day.